Hello again, YouTube. I'm going to talk today about another power bank. I was in a Poundland. I went into a Poundland in a different town. I was visiting the other day, and I just wanted to see if they had anything different to the local one here. Um, and they had this. It's a Power Geek product. It's a little power bank, very similar to the Signal X power banks that they normally do, but it was £2, and primarily it was £2 because the capacity on the box says 2200 milliamp hour. The normal Signal X £1 ones, they are 1200 milliamp hour, and while I was in, I bought one as well, because I've had a couple of these go faulty, and I thought I'll replace one of them. Although I did buy this one, I only bought the one of the £1 Signal X, and this one didn't work out of the box, so I took it apart and had a look at it, got the meter onto it, and the battery was discharged. It was only charged to 2.4 volts, so it was below its minimum, so it was basically over discharged, so the unit won't let you power that up. So to resolve that, I've put it on the bench supply at 3 volts at half an amp and put it on for 10 or 15 minutes, and that brought it up above the cut-off voltage, and it's now charging properly. So the battery was a little bit compromised. I don't think it'll have done any major damage. If it had, it would have probably fully discharged on the shelf, so I'm pretty sure it'll be okay, but I'll keep an eye on it anyway. So the Signal X £1 power banks, they're rated at 1200 milliamp hours. I've never had one read fully 1200. I've had anywhere between 700 and 1100, and over time obviously they drop off. I've actually got quite a lot of the batteries from inside them. You can see this had been used for a while. It was in a power bank that had started to discharge pretty quickly, so I measured it and it's 820 milliamp hour. I've got a few more. Let's see if we've got any more that I've measured. Now this one I've taken out but I haven't measured yet. But I've got a variety of batteries. Some that have come from these power banks, and some that have come from elsewhere. See the heat shrinks falling off that. Need to be careful that doesn't short. But yeah, this is another one from a Poundland power bank. So there's two ways you can measure it. You can measure using something like this. This is a TacLife USB tester, and it's designed for measuring the 5 volt output. So you plug it in, you put a load on it, and it'll measure until the cut-off voltage is reached, so until the battery's discharged, and when you plug it back in again, it'll tell you what the last reading was. Now I just did that with this. I've fully charged it twice, fully discharged it twice, and I'm going to pop this out of its case because I haven't put it back in properly, and I want to use it just to power this up for a second. Okay, so the last reading, so it got to 1099 milliamp hours before it cut off, and this is quite good because it remembers the last stored data, so you can just let the device run until it dies and then just plug it back in, and as long as you don't put a load on it, it won't count up any further. It'll basically tell you where it cut off. So that was it from a full charge, 1099 milliamp hours, so quite a bit short of the 2200 milliamp hour that they're claiming. The other way you can measure it is you can measure the 18650 cell and just put it directly onto a board like this. I've got this one partially taken apart because it's got two load resistors on the back. Let's get rid of that. So you can measure it at half an amp or 1 amp. It's actually about 600 milliamps or 1100-ish. And this basically, you put your 18650 on the two middle terminals. Sorry, they go on the outer terminal. No, they don't. the battery goes on the middle terminals and the resistor goes on the outer terminals. And you set the cut-off voltage on here, and it runs it until it reaches the cut-off voltage, and again it counts the capacity of the battery, This one needs an external power supply because it doesn't remember the last setting. So you plug a 5V supply in here, it does its thing, and the battery discharges through the resistors. Now I haven't done that yet with this battery, the 2200 milliamp hour. I did try it on the 5V output, but it got to about 850 milliamp hours and then cut off. But I suspect that was because the cutoff voltage wasn't correct on here, because it's not really designed to do that. So I'll try that again now that I've got the battery out. This is the content of the 2200 milliamp hour, the £2 one. And if I show you against the pound one, so the Signal X one, let's just frame this properly. They're almost identical. I'm pretty sure they've come from the same factory. On the back of the board, there's only one little difference. I'm just going to bring my magnifying visor down. Yeah, so there's a resistor here. It doesn't exist on the Signal X one. And on the other side, the only difference on the other side is the placement of the LEDs. So on the Signal X one, you've got two LEDs here, and they flash. One's red and one's blue, and the red one flashes or stays solid whenever you're charging, and the blue one comes on whenever there's a load in. This is the £2 one, and there aren't any LEDs down here, but there is one up here. You can see that, it's right up the top. It's actually on the £1 one, the tabs are there, the solder pads are actually there for it, they just haven't populated it. In fact, two sets of solder pads, and that's because there are two LEDs in there. I'll just see if I can get some better light here. Yeah, so two LEDs in the back of here. Okay, and turn these lights off again because they're very flickery with the camera. The shutter speed's obviously been picked up quite a lot. So I'm going to dismantle this. I'm going to take the battery off. What I'll probably do is just put a higher capacity cell on it. I've got some kicking about here. Yeah, I've got these. I was buying these from a company called Next Day Battery, and I went onto their website the other day and they don't seem to have any stock of anything, so I'm assuming the company's not trading anymore. It's a shame because these were good and they were at a good price. However, I have bought a whole load of batteries for another project. Got these, and they're very similar. I've overwrapped these, I put an additional shrink wrap over them to protect them. But these were Samsung Q30, I think they were. They're a bit dearer than these ones, but they were still less than £5 each, and they came from 18650 UK, 18650.uk. I'm not advertising them, I'm not in no way affiliated with them. But they did send them. They came next working day, and they come with a little box, and the service was good. A little bit more expensive, probably about 50p more expensive per cell than Next Day Battery. But if Next Day Battery can't sell you any, then it's a moot point, as it were. So this Power Geek, the £2 power bank. One disadvantage over the Signal X, if you have a look at the Signal X case, Signal X case is dead easy to get open and dead easy to close. So you just push it closed, and if you want to open, pop your fingernail in, use a spudger and just pop it out. That's it. It's also easy to modify these and to put other things in. So, you know, for example, I've got a couple that have got LEDs in. I've got one where the charge circuit failed, so the charge discharge board failed, and I'd bought a load of them from either Amazon or AliExpress, and it's just a slightly bigger charge discharge board, and it's got more connections on it. but I was able to cut away this little bit and put it inside the same case, so they're very useful, especially for £1. And like I say, I buy higher capacity, higher quality batteries, desolder them, wrap them, and I insulate them and put them in these, and then you've got a high quality, high capacity power bank. Obviously it costs you much more than £1, but it's still a lot cheaper than buying a higher capacity one from somewhere like Amazon. So this one, it's a bit more limited. It doesn't have the same case design. It's a nicer case design. It's got a nicer profile, but it's difficult to get apart. As you can see, when I've popped it open, the little clips haven't survived because it's designed in that sort of one-way clamshell, so that the little lugs here, they snap on, and then it's really a case of trying to get these to distort to come off, but they're designed so that they've got a grip on them when it's in use. So it's nicer, but it's not as useful. So if you want to change the cell inside it, it's not, you're not guaranteed that you're going to be able to put the case back together. I've had this one apart twice now, and as you can see, I lost 2 of the clips in the process. There's a set of clips on the other side. They've managed to survive just because of the way I've taken them, but it's just not quite as serviceable, if you like. But that is quite a nice case. So yeah, all in, I would say it's probably not worth paying the £2 for this. Given that you, on test, you don't really get much more capacity. You certainly get a little bit more, but nowhere near what they're claiming. So it's got on here 18650 3.7 volts, 8.14 watt hours, and 8.14 watt hours is 2200 milliamp hour when you convert it. So if this is a genuine cell, it should be given that, but in my experience it's not. Certainly not at 5 volts. It may well be that this is quite lossy, the conversion, because you've got a choke on here that you've taken 3.7 volts and you're bringing it up and regulating it at 5 volts. So there is an induction process happening here, and that is a little bit lossy. You lose a little bit to heat and a little bit to noise, but I wouldn't expect to lose that much. Basically, what I found was that it's giving you exactly half the rated value. So I'm going to take this battery off now, charge it up, and then discharge it using my 18650 tester and see what sort of results I get there. Okay, so I've taken that battery pack out, I've desoldered it, and I've got it charging. I've got the cell charging in a night core charger. So once that's finished, I'll test it. So what I'm going to do now is I'm going to replace the battery pack. I'm going to put this higher capacity cell in the original power bank. In order to do that, I should wrap this cell, but I'm not going to bother. It's already reasonably well wrapped and it's well insulated. It's got plastic insulator in it, so the cell quality is quite good. But what I need to do now is put a strap on the bottom to bring the 0 volt up to the top of the cell. Okay, so this is a nickel strip. It comes in a roll. I've got a couple of different sizes, but I like this little thin one. It's ideal for projects like this. And basically what you need to do is bring it up to the top, enough to fold over the bottom, like so. I'll do it. And then just a bit, just to pop above the top. You don't want it to protrude too much, because there is a risk that if you force it into a case somewhere, it will short circuit. So that's my neutral strip. Now, in order to put this on to the cell, there's 2 ways you can do it. You can try and rough this up and solder it on, but I don't like doing that because the heat's detrimental to the cell. What I like to do is spot weld it. I've got a homemade spot welder here. I'm not going to show you it because it's not finished, and for that reason it's not really that safe, but I'll show you the leads from it. Now for the top of the battery, it also needs a tab, and simply because otherwise you'd be soldering directly onto the battery itself. So all I'm going to do here is take a little piece of the nickel strip and fold it over after I've spot welded on. At this point you want to be really careful because I'm working with a tab here and there's a tab already in the battery. If I was to touch those two, it'd create a short circuit. So just want to make sure that you're working in opposite directions. You don't get anything that's you don't create anything that's going to short out. Okay, and that's my tab. The other thing you want to do is you want to make sure when you're spot welding or soldering that you don't apply too much heat to this insulation ring. If you do, it melts it through, and underneath here the 0 volt, the negative side comes right up, so you'll create a short circuit there. And on a lithium ion battery that would be pretty disastrous. Okay, so we only want a little bit of tab here to solder onto, so I fold that over and cut off the excess. Again, taking care not to short circuit anything. That'll do, that's plenty to solder onto. The nickel strip's ideal for soldering. You'll see that when you get batteries that come out, the Poundland packs, they've already got a nickel strip on them. That's because this stuff's easy to solder onto. It takes the heat away from the cell itself, so you're not likely to do any damage to the cell when you're working with that. The other thing I do is, when I've done this, I just put an extra insulator on the battery. It just means that when you've got that piece of nickel, it's not going to go through and catch anything. These are insulators, you get them on eBay or AliExpress or anywhere like that, and they come with a dot for the middle, so when you're finished you can actually stick that on top here, and it just gives you a better insulation than nothing at all. So my soldering iron's now hot. Oops, helps if I don't hit the camera. There you go. So you can apply the heat to the nickel. Not much of it's going to transfer to the battery, so it should be okay. This tab, doesn't really matter which side you put it on. Again, as long as you're making sure that you don't short circuit anything. There we are. There we go. Let's put that on top. Oops. Okay, so that looks to be lined up properly. So I get the cell in. And then see if the top half of the clamshell will go on. Okay, that's better. Okay, so it's set at 5.1, 5.3 volts at the moment, so basically 5 volts. And I'll test it now. I'll put a load on it. But that looks fine. That's now got a 3500 milliamp hour cell in it. So I'll use that for something like, I've got lights at the bedside that we use as night lights. Or we can use them for reading or just mood lighting. So if we put a cell like this on it, it'll last a fair while. Probably about a week before I have to charge it. Because I only use it for maybe 20 minutes at night when we go to bed. Okay, so I've just taken this cell from the £2 battery pack and I've charged it in this Nightcore i4 charger. So it's at full capacity, it's 4.2 volts. I'm not overly concerned about how good the soldering is on it, because it's only on there to be tested. Okay, so now I'll bring in the Signalex battery box. Sorry, power bank. We use battery boxes at work because I work with control systems and they're all 24 volt. So I've got a lot of boxes that we make that contain 2 batteries or 6 batteries. I'll just quickly show you one that's in progress. There's one here. So it contains a battery pack, some relays, switches, a little display, and here's the output. So I keep talking about battery boxes because that's what I'm used to working with. This is one I've actually destroyed. This little board here, I accidentally shorted out the charge point, and I don't know if you can see that, but there's a big hole in that MOSFET there because I shorted it. So I need to replace it, but I'm modifying it as well so that can't happen again. So basically, instead of having a DC jack, we're putting XLR jacks in so that you can't accidentally short them. And also putting a relay in so that the charging port isn't actually connected until it has a load on it. Anyway, back to this. So the way this works is pretty straightforward. There you go. So plug it in and it's at 4.2 volts, 4.18. You can set the parameters on it by using these buttons. The P is the cut-off voltage, so it'll cut off at 3 volts, and that's generally where a lithium-ion battery should be cutting off at. So when you're measuring the milliamp hours capacity of a battery, a lithium cell, that's where you're measuring it from, the difference between the battery at 4.2 and the battery at 3 volts. You don't want it to drop any lower than that, it could damage the cell. Okay, so basically we switch this on now, on at 3, and there it goes. So it's now telling us that it's 4.6 volts under load. It's consumed 0.2 milliamp hours, sorry, 2 milliamp hours, 3 milliamp hours. 1.08 is the ampage that is drawing through these 2 resistors, so it will now continue to do that until the battery is fully discharged, and when it's finished we'll come back and see what the reading is. Okay, so the battery's been charged, it's been discharged, and it's gone through its full discharge cycle, so it's now down at 3 volts and it's 1842 milliamps. So it's quite a bit more than I expected, to be honest. This is basically measuring directly off the battery, so there's no inductor to worry about, there's no step up, no boosting going on in the voltage, there's no loss through that, there's no loss through heat, it's just simply discharging through these resistors. So it's actually not too bad. This cell's usable. I'll keep this and I'll use it for various, I'll put it back in a power bank basically. I think it's got a much higher capacity than the £1 ones. Quite surprised actually, because I was expecting it to be a lot less. It's still, I think it's still a little bit, it's not, the rating that they put on these power banks isn't that honest. I mean, clearly 1842, okay, if I'd run it right down to 2.7 volts maybe, I'd have got 2200 milliamps out of it, but you start to get to very close to the point where you don't want the battery running that low, because if you run it that low and then leave it for a while, it won't come back up. So it's not a safe voltage to drop it to. The other thing is that these the power banks themselves, they've got a milliamp hour rating on them. So these ones say they're 1200 milliamp hour. When you take the batteries out and you do that test on them, you don't get anywhere near that. You get 800 or 900. I think the most I ever got out of one was about 1100. What you're more interested in is what you get once it's been converted to 5 volts, because that's what people use them for. Not really interested in what it's at, when it's at 4.2 volts. I want to know how much power I'm going to get once it's been converted. But I guess that's never going to change. Certainly not with the Chinese manufacturers. Excuse me. And I'm not expecting the pound shop to go off and up the quality on the way they measure things. It's a pound. It comes from China. We all know where it comes from. We all know what to expect. It does what it says, really. It doesn't give you 1200 milliamps or 2200 milliamp hour at 5 volts, but it's a power bank. It's a pound or £2, and it charges your phone, or it charges whatever, it gives you a little bit of power. So all in all, I'm quite surprised, quite pleasantly surprised at this. Gives it a little bit more power than I expected. But overall, would I buy these rather than the £1 one? Probably not, because, well, for me, I don't use them very long with the cells that come with them. I tend to open them up and change the cell, because the little board inside's what's more important. It does its job pretty well. Thanks for watching my video. If you like this kind of video, if you click like and subscribe, I would appreciate that. It'll encourage me to do more.